Hello, welcome to my first organic class, which is very conceptual and based on CBSC and state board syllabus. Today I am going to discuss on organic chemistry second year. Chapter is aldehyde ketone and carboxylic acid. Out of the huge chapter, I am going to start specifically on carboxylic acid. So first of all, I am giving you the first map of the structure with which it is dealt with. The structure is about introduction, number 2 classification, number 3 preparation, and number 4 physical behavior, number 5 chemical reaction or behavior. Step by step, at the very beginning, I am starting with introduction. Since the name of the chapter is carboxylic acids, so what is carboxylic? Actually, carboxylic acid is, it is carbon containing compound which contains COOH group as functional groups are called carboxylic acid. Carboxylic acid is mainly consists of two parts. One is carbonyl part and other is hydroxyl part. From carbonyl part, the word carbo has come, and from hydroxyl, the oxyl appears. Combining these two, the name carboxyl group comes. So now, carboxylic acid may be of two types. One is alkyl, aliphatic carboxylic acid, and other is aromatic carboxylic acid. Here R is alkyl part, may be methyl, ethyl, etc. And here is aryl means phenyl part. Now, this carboxylic acid, when lower members are liquid in general and higher member of the order carbon 12 to carbon 18 are called fatty acid. And these fatty acids actually occurs in nature in fats in the form of glycerol. So now, out of fatty acid, one is palmitic acid, and other one is stearic acid. These are two examples I am giving. These are best examples of fatty acids are palmitic acids and stearic acid. These are being used in preparation of salts. Now second part is classification. In the classification, we can say carboxylic acid actually maybe of monocarboxylic acid, dicarboxylic acid, tricarboxylic acid, etc. That mono, di and tri depends upon the number of carboxylic group present in the structure. If there is one carboxylic acid, these are monocarboxylic acid, say HCOOH, CH3COOH, etc. Dicarboxylic acid, if COOH, two groups are attached, COOH, COOH. Tricarboxylic acid, if three COOH groups are attached. Maybe one example is propane 1, 2, 3 dicarboxylic acid, or citric acid may be one of the example of dicarboxylic acid. Now preparation. One thing I left out. Monocarboxylic acid, it is say it is formic acid. Maximum of the carboxylic acids are generally found in nature. So say formic acid, its source is reagent. Another is acetic acid. Source is vinegar. Another is capric acid. Source is goat fat. Butyric acid. Source is butter. So these are some monocarboxylic acids. These are very often found in nature, from butter, from reagent, from vinegar, from goat fat. Say dicarboxylic acid. Dicarboxylic acid maybe COOH, oxalic acid, or ethane 1,1,2 dienoic acid. Another is propane 1,3 dioic acid, butane 1,4 dioic acid, pentane 1,5 dioic acid, hexane 1,6 dioic acid. It is oxalic acid. Second one is malonic acid. Third one is succinic acid. Fourth, glutaric acid. And last one is adipic acid. Now, the next part is the preparation. Generally it is prepared from alcohol, from alkyl benzene, from nitrile compound, from amide, from Grignard reagent, and from ester. These are some important things from which you can prepare carboxylic acid. One is from alcohol. Just to follow from alcohol. So before starting this one, let me first write some of the oxidizing agent. Very important oxidizing agent are K2Cr2O7 or KMnO4 or Jones reagent. Important reagent, Jones reagent. It is sulfuric acid dilute plus chromium trioxide in acetone. These are the some of the important oxidizing agents which are important in preparation, especially on this chapter carboxylic acid. And some other things are also there. Mild oxidizing agent. One is sodium hydroxide plus iodine in iodoform reaction. In aldehyde chapter I will discuss it. And other is tolerance or failing reagent. These things are from not alcohol, from aldehyde and this. But iodoform is again from alcohol, and tolerance and failings is from aldehyde. So let us see how we can obtain carboxylic acid from alcohol. Say CH3, CH2OH, KMnO4, potassium hydroxide, something alkaline position, will get CH3, COOH, carboxylic acid. This is ethanol, ethanoic acid, acetic acid. Am I right? So the fact is that, just to keep it in your mind, that CH2OH groups converts into COOH. Again CH3, CH2 whole thing 8, CH2OH, Jones reagent, that is sulfuric acid. Earlier I have written, I wrote it, hydrosulfuric acid, dilute condition, chromium trioxide in acetone, we get CH3, CH2H, COOH, decanoic acid. So again you see here in oxidation we have got the CH2 part has converted into COOH. Now, one of the simple thing I am explaining here is that if you cannot keep it in your mind that how CH2 group converts into on oxidation converts into COOH. Now just you follow me, you will understand it. And this is the original process but not the mechanism. You see, when oxidizing agent is given here, one hydrogen from O attached to carbon and one hydrogen from carbon will be removed. So oxidation here means removal of hydrogen. So what you get is CH3CHO. We are getting CH3CHO. Since the oxidizing agent is strong one, it will again further oxidized. So what's happened here is actually in dilute, in Jones or D, you are getting water and water is broken into OH negative and H positive. Am I right? Breaks up in this way. And we know that in ketone, oxygen is more electronegative, so electron bond is drawn towards E. So generally O becomes minus and C become plus. So here OH and H part, H positive part comes to CH3CHO. You give it a single bond and along with O is negative O attached, and negative part C is plus attached here. Am I right? So finally what happens? Finally from this one, since it is oxidation process, again one hydrogen from that carbon and other hydrogen from that carbon removes. So we are getting CH3COOH. CH3COOH. Am I right? If you find it difficult to keep it in your mind, so one thing in your mind that CH2OH first oxidized into CHO and simultaneously it converts to COOH. Now that part is over. Next is alkyl benzene. We are taking example of toluene. Toluene. It is toluene. Alkyl benzene on oxidation say KMnO4 potassium hydroxide. Oxidizing agent is strong oxidizing agent is there. KMnO4, LO4. You can write KMnO4 oblique potassium hydroxide in alkaline base. It simply transforms into COOH. Again, if you write it in this way, ethyl benzene, again KMnO4 potassium hydroxide, again you are getting carboxylic acid. But one fact is here, one more I am showing you. If it is like this, two CH3 group is there. Again you are getting same benzoic acid. But the fact is that next alkyl benzene, if alkyl part is 3 degree, very important thing, just to see, it is CH3, it is CH3, it is CH3. It will not undergo any oxidation because so long you have got one hydrogen attached with carbon which is attached with benzene ring, there is oxidation. You are getting COOH. But As soon as no hydrogen is attached, left with carbon attached to benzene, no hydrogen left, carbon attached to benzene, then oxidation is not possible. And one thing left is, in Jones reagent, generally 1 degree alcohol becomes carboxylic acid and 2 degree alcohol becomes ketone. Just keep it in your mind. So that part is over from alkyl benzene. Now from nitrile. Nitrile means CN group, compound with CN group, CH3, C triple bond N, acid hydrolysis means acid in presence of water. Your answer is acetic acid, ethanoic acid. So very simple way, the shortcut is CN group transformed into COOH groups in presence of H positive and water, means acid hydrolysis. It is very often in another chapter also you will find this one. And if you tell now how, without mechanism, just I am explaining. It is not mechanism, shortcut I am showing you. See, nitrogen mode, electronegative, bond is withdrawn in this way. So nitrogen is minus, this is plus. In acid hydrolysis, presence of acid, water is broken into H plus, O is negative. So negative part, that is acid, I am showing you here. CH3, C double bond has been withdrawn here, it has become minus, and this is plus, along with nitrogen minus. So water has broken into two parts, O is negative and H plus, then H plus will get attached with the N, and carbon is plus, that O is attached with this. Now there is rearrangement. That hydrogen comes over there. So you are getting CH3, C bond O, double bond N, H. Whenever hydrogen comes here, there is double bond 1, 2, 3, 4. That bond will be withdrawn here. So you are getting CH3, C double bond O bond NH2. So finally you are getting what is CH3 bond CO NH2. Is it not amide? This is amide. That on acid hydrolysis, further acid hydrolysis, it gives that part is minus and that part is plus. So you are getting OH minus and H plus. So that is not mechanism, just you break here and add minus OH part to C. C is plus OH with it. CH3, C, OH, and double bond OH here, and H2. H part get attached with this one, and OH is that part. OH is left and H is that right part. So you are getting this CH3, C double OH. This is the simple way to keep it in your mind. Otherwise, the method is CH3, C triple bond N on acid hydrolysis gives you CH3, C double H, that is CN group, functional groups, converts to COOH when it is acid hydrolyzed, and the way it is converted into CN to CH I have shown it a bit earlier. Next one, from amide, from naphthalene from amide. Amide means a bit earlier I have shown you that is amide. CONH2 group is amide. That amide on acid hydrolysis, simple earlier, water has broken into H plus and OH negative. Am I right? So this is withdrawn in this way. You keep it. It is not mechanism. For simple shortcut method, this is plus and another part is minus. So that plus part, minus part, you add this one CH3, COH and C. It is not mechanism. Once again I am telling. COOH plus H part comes here and OH part comes here. In this way it backs. Am I right? So you are getting Na. So if it is like this, CONH2 and it is acid hydrolyzed, again you are getting COOH plus ammonia. The way which I have shown earlier is the same for both the cases. So you have got amide. Now you minutely follow one very important one is Grignard reagent. So before starting how to get carboxylic acid from Grignard reagent, let me first give you the example of Grignard, that is RNGX, maximum of you know. R is an alkyl, methyl, ethyl, propyl, etc. Magnesium is magnesium, it is metal, group 2, and X is halogen, any halogen, chlorine, bromine, etc. So here it is called organometallic compound. It is called organometallic compound. It is very important in organic chemistry because out of this a lot of synthetic products can be synthesized. Hence it is a immense use in the organic chemistry. In alcohol chapter you will get RNGX. In alkyl halide aryl halide chapter you will get MGX. In aldehyde ketone chapter you are getting this. In carboxylic groups you are getting this. Each and every chapter you will get RNGX because it is very important compound synthetically. So let us just give one example of a Grignard reagent. Say methyl magnesium bromide. Here one thing is very important. Whenever you write a Grignard reagent, you keep it in your mind that is metal. Metal is always plus. I think you always keep this is plus in your mind and that is minus. Don't forget to mark it in this way. In this way, and you make to react to it carbon dioxide because we need carboxylic acid to prepare. So carboxylic means COOH group should be introduced in that one. So COOH group should come from carbon dioxide. So we are using carbon dioxide. So what's happening in carbon dioxide? Oxygen is more electronegative than carbons and bond is withdrawn in this way. So it becomes partially minus and that becomes partially plus. So the fact is that you write here O double bond C single bond O, that is negative, that is positive. So that CH3 is the negative and that is positive. CH3 is negative. Negative part will get attached with this one and positive part will get attached with negative part. So if you don't follow this, it's totally impossible for you to get the correct answer. Next and last part is always Grignard reagent. After this there is hydrolysis. So acid hydrolysis means H plus and OH negative is there. So you break this here. O is negative. So in negative part you add bring H, and in positive part you bring OH. So finally you are getting CH3 C double bond OH, and this is byproduct side product MgOH. Very often this question asks in NWT. If I am not wrong, this question has appeared in exam 2001, NEET 2021. So next and last preparation is ester, from ester. What is ester? Ester is actually C double O group if it is attached to the compound is called ester. This is ethyl benzoate, I think. Ethyl benzoate. C double O IUPAC name is 8. Okay. So if you hydrolysis acid hydrolyze, if you hydrolyze it, that breaks into this. Again water breaks into this. That O is negative part, so positive part will come here and negative part goes there. Simple, it is not mechanism, simple way. Very simple. You are getting benzoic acid and ethanol. This is all about the preparation of carboxylic acid from alcohol nitrile amide, alkyl benzene, carbon dioxide, the Wigner reagent, and ester. Now let me come to physical behavior. Physical behavior. So carboxylic acid, even in vapor phase or in aprotic solvent and or vapor phase, the intermolecular hydrogen bonding is so strong it doesn't break. I will explain the term aprotic. So intermolecular hydrogen bonding, we have got it earlier in higher secondary first year. That's why lower members of carboxylic acid very often appears as dimers. Two molecules get attached, and their intermolecular hydrogen bonding is so strong even in vapor stage or in aprotic solvent. That's why their boiling point is even more than aldehyde, ketone, alcohol of comparable masses. So one of the fact I am explaining here is, say, there is also intermolecular hydrogen bonding in alcohol, ROH. But in case of carboxylic acid, that is too much strong. That's why Carboxylic acid is having stronger hydrogen bonding, intermolecular hydrogen bonding than alcohol. So now let us explain the acidity. Since the chapter is acidic carboxylic acid, so now what is acidity? Let us explain. Say R COOH, say in water, aqueous solvent, we very often get this. That is, a species or substance is acidic only when it can release hydrogen as proton. So this is acidic because RCOOH, it becomes RCOO negative plus H3O positive. So also, if you compare alcohol, here also the same matter occurs. It gives alkoxide anion and this. So both are acid. Now let us explain which one is more stronger and which one is weaker. So mind that acid is a species which lose hydrogen as proton. So in both cases, both the substances are capable of losing hydrogen as proton. Now, in case of carboxylic acid, when it loses hydrogen, it becomes this. That is, if you write in this way, you are getting this. This is actually this. And now this happens so. So one time it is remaining in this way, other time it is this, again it comes this position, it goes to that one, gives you the initial one, that is called resonance. So in carboxylate ion, the negative part or anion part is resonance hybridized, where in case of alcohol, when it loses one hydrogen as proton to act as an acid, it becomes alkoxide ion. No resonance stabilization of alkoxide part appears. Hence, this part is more stable, this one. So acetic acid is more acidic than alcohol. Now plus I group, let me explain a bit. And minus I group, we know alkyl part CH3, C2H5, etc. Plus I group, all halogen, nitro, etc. Minus I group, plus I group means those are groups or elements or atoms. The species which has the ability to pump electron to release electrons are called plus I groups. And here halogen single or groups NO2. These are the that can withdraw electron from the chip. So inductive effect you have got in first year, you know it very well. So this plus I effect and minus I effect has got tremendous effect on acidity of carboxylic acid. Say HCOOH and CH3COOH. Both are acid because both can release hydrogen as proton. But that release, in this case, there is plus I effect. Electrons are pumping through in this reaction. That's why the electron density of OH bond increases and release of hydrogen as proton becomes a bit hard. But here no such effect is there. So formic acid is stronger than acetic acid. Now FCH2 COOH, ClCH2 COOH, BrCH2 COOH. I will explain the acidity. Here minus I groups are attached and it is 17 group elements, am I right? fluorine, chlorine, bromine group wise in this way. So electronegativity decreases. Smaller the atom, higher is the electronegativity, and electronegativity effect of fluorine is more. So electronegativity increases or facilitate the release of hydrogenous proton. So that one is stronger than this, than this. Now, if you increase the number, say CCl3, CHCl2, CH2ClCOOH. And if I ask you, arrange in increasing order of acidity, naturally order of acidity is this. Again, third case, distance, CH3, CH2, COOH, CH3, CH2, COOH, CH3, CH2, COOH. If you enter one chlorine here, then one chlorine, CH3, CH2, CH2, COOH. From one compound I am showing you, if you enter chlorine here, say it is A, now keep it same, you enter chlorine here, now say this is B, keep it same, now enter one chlorine here, say it is C. So in case of earlier A, chlorine was very close to COOH, and in compound B, chlorine was second carbon, attached to a second carbon to COOH, and C, chlorine is at the end. If the chlorine attached, the distance from COOH increases, the minus I effect diminishes. So here A will be more acidic than B, then C. In acidity, one of the fact is pK value. Dissociation concept of acid is inversely proportional to acidity. More the value of pK, less is the acidity, or K is directly proportional to acidity. Now you can ask me, how can I write pK and K, where from it comes? It will be a lengthy class, so it has actually come from equilibrium constant. Say in a short I am writing you, you will find CH3 COO negative plus H3O negative, K of A, K is equal to equilibrium, CH3 COO negative, H3O positive, negative 3, CH3 COOH, and water. Then that water is constant, you bring here, K equilibrium into concentration of water, so you are getting CH3 COOH and CH3 COO negative, HO positive, and that two combined gives you dissociation constant of acid. So dissociation constant acid Ka I have written earlier, is equal to K equilibrium into dot hydrogen ion concentration is equal to this. And we know Pk is equal to minus log Ka. So the relation is reverse. One is inversely proportional, other is directly proportional. It is directly proportional to ionic concentration. Value of K is more, it is more acidic. Value of K is less, less it is. If it is directly proportional, so it is linked with the log. Pk is equal to minus log K, so it is inversely proportional. Am I right? One last of today's class is 100% pure acidic acid at temperature less than 289 Kelvin is icy solid called glacial acetic acid. In organic chemistry practical, you have got this word glacial acetic acid. Acetic acid. This is the last part of today's class. Today I have concluded this one. This is the first class. Next second class, I'll just shortly I will give you the idea on chemical behavior, which is very detailed and very important. And if you follow this one, you can very easily solve yourself. You should not be based on lecture. Your nature should not be based on lecture only. You should apply your mind. Whatever I have learned, you just to apply in solving out the problem. This is the weakness of the student. They are always lecture oriented and they never try to apply their mind to apply the concept of the classes in solving out the problem. Thanks a lot.